So today I'm going to be talking about how Yammer builds services, how we do this alongside Rails, and talk about some of the things that maybe we don't talk about very often. So this is me. My name's Brian. I work on the Rails team at Yammer, and one of the things we do is we take things out of this monolithic Rails app that we have, and we put them in services. And the Rails team helps the core services do this, and then we integrate that back into the Rails app. So, like I said, this is me. I love Zelda. I love video games. I love music, and I'm really excited to be here. This is my first time in Europe. I gave my first conference talk like 2 days ago, so I'm kind of scared, but this is awesome. So, thank you guys.
So another applause for Brian.
All right, but first, like I said, I haven't given a talk in a long time, probably since college. So when I started putting this thing together, I thought about two things. And one of them is that I have a pet peeve about titles of talks. And that's when there's a title and they never like talk about what the title, like never get into what the title was in the talk. So I want to make sure I do that. And then also I had to find a template to make this thing look good. So as you might know, Yammer is owned by Microsoft now, so they have tons of templates. So I went through a bunch of these things, and I found this in one of the templates, and it said full bleed photos, pictures can set a mood or evoke emotion, making for a more memorable presentation. So I copied and dragged that slide over to here. And I decided I was going to use this guy to help me convey that message of whenever there's some shit that we don't talk about, you're going to see this guy on screen, and you're going to see a message about that. So here he is. Here's the first one. So this talk might not apply to you guys yet. If you're building a startup to determine viability, just ignore a lot of this and get it done. You're going to add a lot of complexity building services, and you probably don't have enough information yet to do this. Once you know you need to scale, you're going to have to do some things that make you uncomfortable, though. And those are some of the things I'm going to talk about. All right, let's continue. We have a huge fucking Rails app at Yammer. We have over 300 models, 200 controllers. This thing is backed by over 20 JVM services that we've built. And some of these services do over 1 billion requests a day. But we still have a huge Rails app. It's still, this gets harder as we go too, but largely we've been okay with it. We've been able to address it through pulling these things out into services, kind of chipping away at the problem. But things are still really painful when you get into things like sharding or upgrading Rails, upgrading Ruby. These are all or nothing things now when we do that. So I'm going to talk a little bit about service-oriented architectures, why we build services, what it gets us. And I think the first goal is this. We want components that scale individually. One of the goals of services is to achieve this. When you have small focused services, they're more versatile. They allow for much easier reusability. So here's a situation we have at Yammer. We have our Rails app. These are some of the services we have. It's an indexing service and our search interface. And when we started building this, because of some prior search experience we had, we knew we needed to do this in 3 chunks. So that these pieces could scale individually, so that they could be reusable. So this piece in the middle is a denormalized data store. Anything that goes into Rails, we kind of mirror it over to there in a denormalized state. And then a lot of our other services use that. So we built this. This is, like I said, our search interface. And then when we wanted to add autocomplete to this, it was really easy. We just kind of put it into the pipeline, reused a bunch of pieces we had. And the same goes for this last service. We call it Slurpee. It's our data export service. So we could take entire chunks of data that were in our denormalized store already and just export those with this service. And this is great because now we have all these pieces that we can scale out individually. So that's another big win we have is scalability. It's much easier to scale out a service. We have these known and predictable usage and performance patterns of a service. Like I said, it's much more focused. And we don't have to throw resources at the whole stack. They may or may not be needed. And so all of this is kind of enabled through another benefit. And that's this loose coupling. Like I said, again, we have these smaller and more focused services. We've encapsulated our concerns behind these services. We can push out updates independently to any of these services. We don't have to have these giant deploys of one Rails app. Well, we still have that, but we can move the smaller pieces along in services. And then we can change out everything without telling anyone. Granted, we have to keep the interfaces the same, but that's a different problem we can deal with. We can change out an entire library, a technology, a platform, and if we're doing it right, we don't have to inform the clients of this. We're doing this right now. We're switching out our files back end. It's gone mostly smoothly. We can take out that entire service. Currently, it's a Node.js service. We're getting away from that. We're going towards a JVM service for it. And so largely, it's gone pretty smoothly. And so this is kind of another goal we have in service-oriented architecture, is that we want code bases that scale organizationally. If you've worked on a monolithic app before, you've probably stepped on other people. And one of the hardest things is you have to have all this knowledge of this huge application in your head at all times. With services, you can kind of break that down and go in on a need-to-know basis to learn these services. And so with this, we get distributed execution. This is enabled by loose coupling. We can assign a team to the service. We can have these two different teams coordinate on the APIs, and they can agree on these things. And then we can use dummy components. So as we're building the service and we're doing the integration in Rails, the Rails team can hit this endpoint that doesn't exist yet, and the core services team can build this endpoint that doesn't do anything yet. So we can send bad data or incorrect data, and we get this endpoint that really isn't implemented yet. But as we go, both these teams are building their parts, and then at the end, we can have this full end-to-end test that we can do. And so here's the dude again. This doesn't happen overnight, and as I talked about a little while ago, when you're starting your startup or your application, this adds a lot of additional complexity that prevents you from shipping quickly. With a single undivided code base, you have the freedom to change things quickly, access data layers, share a lot of code easily, and just generally avoid all the overhead that you have with services. But these are things we can learn along the way. We can iteratively do this, but you're not going to wake up one morning with services. And we found that sometimes this requires organizational change as well. At Yammer a lot, we talk about Conways Law, and kind of the premise is that organizations that are optimized to avoid bottlenecks will also create code that is meant to avoid bottlenecks. This is what the law says. Organizations which design systems are constrained to produce designs which are copies of the communication structures of these organizations. It's hard for us to think about services unless we think of our development teams in the same way. A lot of organizations will divide their departments vertically or horizontally, which leads to silos within the organization or people working on the same things day to day. So this barrier forces people to get attached to their turf. It inhibits communication and decision making. So we in the beginning at Yammer, we kind of divided this way. It looks something like this. We had this team called the messaging team, and they were obviously responsible for messages, and their responsibility kind of looked like this. And so they built this service, and they also owned the integration side as well. They took on both sides of this implementation. So like I said, they decided on both these sides. They have a really siloed knowledge of the system. And we found that it's not always the most important thing that they could be working on. There's other things we want to build. Messaging can maybe take a back seat sometimes. And this model doesn't scale as well. Do we keep creating these feature teams to build these features? And so we moved to more of an approach like this, where we had a Rails team and we had this core services team. And the Rails team would still have to know a lot about this monolithic app. But as we move these things out into services, the idea would be that we could iteratively reduce this knowledge. But we needed to take this a step further as well. So we use what we call cross-functional teams. When we're creating a new service or feature, we put together one of these teams with representatives for every aspect of the project. And it looks something like this. And so this is an example of a cross-functional team. We've taken resources from all of our functional teams. Say on this project, we have 2 Rails engineers. We have a core services engineer. We have a mobile client engineer. And then we have some other roles as well on the product side. So these teams, this creates an autonomous, well-informed, decentralized design process. These teams have a lot of discretion, and usually it yields well-designed, isolated, reusable systems when we build it this way. And the key here is that this team is ephemeral. It comes together, it solves this problem, and then we disband, and then we move on. Another kind of cool little point we have is one of these people will be a tech lead for the project. It's kind of a rotating position we have, so not one person is ever like fully managing these things. And so one person will kind of oversee this thing, and then the next time you'll be more of an individual contributor, and it will just keep rotating. So our cross-functional teams, they spin up, they learn the domain, they take advantage of distributed execution. All of these teams can be working on something at the same time. And the team coordinates on the API between the services and the client. And the result of this is we have these naturally occurring services whenever these teams come together. So this does have some trade-offs as well. We've come to terms with some of these things. We do have some costs with not having siloed experts. Some would probably agree that this is a benefit, but there is a cost involved with teams constantly having to learn a new domain. We don't have like the messaging team where they know messages and we go to them. Every time we start up a team, that team might have to learn what that domain is, and we're okay with that. Another kind of issue that comes up time to time is when we're building these things for a feature, we have to be careful not to couple the API implementation to the client. When we are building a feature, sometimes it's easy to get carried away with this, and we have to really think about, is this good for just this feature, or is this our overall vision of this? And then after the project's completed, we still have to support this feature. There's not the messaging team that takes care of all these support tickets. Now something else has to take care of this. And it's people, like I said again, that might not be as familiar with it, so there's some cost involved with that. But we're okay with these things. So there's more than one way that we do this. It looks a couple different ways. So it's probably going to look like this for a while. We did change our organizational structure, but these are really hard problems to solve. And one of the easiest solutions to this is just kind of putting all these services behind Rails and not letting the clients talk to them directly. So these services can have their own data stores. We're not concerned with that. And this gets us a lot of win. But we still have to use Rails resources to get to these things. So there's trade-offs there too. We can also talk directly to a service. The browser can go get things. Eventually, we'll want to do this so we don't have to go through Rails. And sometimes it's easy. We have a service called Mugshot that handles dynamically resizing images for us. It does our avatars. It does some other images as well. And we can hide the caching and all of that behind this service. And that's pretty easy. But eventually, you're probably going to have to figure out authentication if you want to do this. And things start to get harder. So there are lots of different ways we can do this. But there will probably come a point when you want to work around Rails to get to your data. Usually a lot of as our app grows, all of our data has been in Postgres or whatever store you use. And reading from the database from a service, it's not the worst thing in the world, but it's not great either. But writing that database can be a nightmare. The problem with us for reading is that Postgres isn't our database. Memcache is our database. Rails knows about our caching layer, but our services don't. So this is hard because Active Record kind of holds our data hostage. And that's fine. We got a lot of win in the beginning out of this. We were able to build our app quickly. But now we have to start to tear down some of this that worked well. And don't get me wrong, Active Record can be awesome. It does help you get going really quickly. You have all these callbacks, you have hooks, you have validations. We can do our state machines with it. We can hook up cache invalidation pretty easily. We use a gem called Record Cache that handles storing all of our records in Memcache. We hardly ever hit the database, and we rely pretty heavily on a gem for this that integrates with Active Record. And so all this stuff is awesome until we start to detangle this data and try and access it to a server, or access it from a service, or try and move it out to a service. And then it kind of turns into this, Active Record. We have all these callbacks and hooks we have to worry about. We have all these validations we have to worry about. These state machines, we have to move that logic. Now we have to worry about cache invalidation other places. So we do have some options. Some people can choose not to use Active Record. We use it, so that's not really an option for us. One of the things we do quite a bit is we use our services kind of as indexes. We store a lot of IDs in these services, and as we pull things back in through Rails, we'll hydrate some of these relationships and push it back out through Rails. And the other option is to move the data so the service owns it. So let's talk about that. So moving data probably means that we're going to duplicate data. Once we're ready, once we've decided we want to move this outside of Active Record, if you're like us, you probably can't have downtime. That's not an option for us to stop this application, move our data, pull it back up. And then what if the service doesn't work as we intended it to? We need a backup plan. Rolling back is hard to do. So we want to be able to do this incrementally. So how we do that is with double dispatching. We would backfill all the data to the service. We would write the data to the database and the service at the same time. And as we're doing this, we can monitor the service, we can profile it, and we can kind of move over incrementally. We can start changing where we send traffic for things. And the backfill is really cool because it's kind of a peek into scalability. We're going to be pushing a lot of data into the service really fast, much faster than we typically would be in production. And we can see how we handle that. We can use this to plan capacity and just generally know how we expect this thing to perform. So once we've done this, though, now we have duplicate data. And who cleans this up? We need to do it quickly because developers are going to become confused. They're going to see data in Rails, they're going to see data over here, and it's not going to be massively apparent which is the source of truth. And we do fuck this up from time to time. Data sticks around for a while, it's confusing. And this is part of the trade-off we make in our cross-functional teams is this team implements this thing, they disband, and now we have to worry about cleaning it up. And so this is one of the problems is the old way is comfortable. We have this escape route, this backup plan that if this service doesn't work out, all of our data is still in Rails. We can just go back to it. But we have to be okay with breaking our comfort zone and dealing with these new issues instead of just being able to jump ship. Don't get me wrong, though. You don't want to strand yourself. You want to move incrementally. But eventually, you just have to make that call to make the switch. There is a cost with maintaining that backup plan, and a lot of times it's not worth it. So on that note, make shit easy for developers. If you don't have a good story for your development environment, you're not going to be able to move very quickly. At Yammer, we have about 150 engineers, and so this becomes really important for us. Like I said earlier, part of the big one of services is not having to worry about configuring them, setting them up, taking 2 or 3 days to set your whole environment up. And then when you do need to learn about the service, you can dig in at that point. And if this isn't easy, developers might wander back into their comfort zone. Basically what I'm saying is use Vagrant. If you guys haven't heard of it, it's a way to bring up a virtual environment, bootstrap it pretty easily. We use this extremely heavily. And so our development environment is close to production. We run Ubuntu both on the virtual machine and in production. We can have all these services running locally, although this gets harder. We have 16 gigs of RAM in our laptops, and we're starting to not be able to run all these services at the same time. But that's a solution we can address or a problem we can address when we get to it. And then we also need to keep up with these services that are also rapidly changing. This is a tool that we've built in-house that we run in Vagrant. This allows us to keep all of our services up to date. It tells us when things are out of date. As a developer, I can just come here, click update, 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 and I don't have to worry about what these services do. I can just go get shit done, and then when things are not looking great, I can come here and figure out what's wrong. And so we need a way to deploy all these services as well. For developers, they need a system that they can add these things to quickly. We need to make it easy to deploy each service. For us, we need to maintain stable and pre-release packages for our development environments. And so we have another tool that we've built in-house for this. Sadly, it's not open source yet, but we talk about it a lot. That doesn't mean anything, but we talk about it a lot.
Keep talking.
We've coupled, this is pretty coupled to a lot of our conventions, so that makes it harder. But we have talked about what we can do to open source this. But essentially it allows any engineer across our entire organization to deploy these services really quickly. One-click deploys all of our applications. It allows us to keep moving quickly. Another thing that your developers are going to need are performance and alerting. We do performance monitoring. We do a little bit with New Relic, but we also have a tool that we built in-house that allows us to time blocks of code in Rails. We have a metrics library that we use in our Java applications that allows us to pull everything together in Ganglia. We alert with Zabbix. And yeah, this is another thing that your developers are going to need. And so having these standardized tools, not only these tools, but also thinking about things like response formats, data protocols, monitoring interfaces, deployment stories, all of these things, it's going to make your world a lot easier if they're all the same and you don't have to worry about all these unique and special little snowflakes everywhere. We have this library that we created. This is what all of our JVM services are backed by. It's called Drop Wizard. We basically package together all the libraries that we use and a lot of the conventions that we have. And we get these really simple production-ready services that are monitored, logging, alerting, all of these things pretty quickly. And this doesn't mean you have to use Java. We have some historical and some performance reasons for this, that we build our services in Java. But we haven't discounted Ruby for a lot of these things. We've started to talk about these bodega services as we start to move data outside of our Rails application and have all these different services that we go to for that data. And it's a large possibility that we have all this domain logic written in Rails to move these to Ruby services. And then if it's still an issue, we can address that as we come across it. And so services have trade-offs as well. They have drawbacks. One of the most important ones is that complex systems fail. And you need to think about degrading for unavailable services now. Also, chasing issues through multiple levels of indirection can get difficult. People don't know where the problem's happening. The place throwing the alert might not be causing the issue. You have a queue backing up, but it's because the services become slow. And so you have all these new concerns now. Some other trade-offs that we have, like I said, handling availability. Transactions aren't completely free, so now we have to worry about the extra overhead of hitting these services. APIs are much harder to change. And we don't really have an atomic deploy. When we deploy a service, it's going to have clients coming in at both sides of it, of the implementation. So we now have to worry about that as well. We've tried coordinated deploys in the past. That's extremely difficult. It doesn't usually turn out well. So you need to support both sides of this thing. So to recap, we always want to be reevaluating our costs and their viability. And I don't mean the financials. I'm talking about the decisions you've made, and if they're still the right decisions. Are you okay with the trade-offs you've made? Is something slowing you down? Know what the inflection points in your application or software look like, and know what that means to your software. But don't scale before you need to, but be ready for it. And once you've determined that you need to scale with services, and you can take on that additional complexity, you're going to need an organization that supports building services. And this could be much more than just your development structure, but it means giving priority to building the tools you need, creating a culture around systems. And some things are going to get a lot harder. Development is going to be more complicated, but that's okay. The amount of required effort in some places as the system gets larger is going to be much more reasonable and manageable and easier to reason about. We also need these tools that allow us to keep moving fast. Building services can't slow you down. You still have customers, and you still have to deliver value to them. And they don't and shouldn't care about any of this. But if things break, they're going to care. And if developers can't build services easy and they're up against a deadline, they're just going to start adding to the monolith, taking an easy way out. It's easier for them, and they can worry about it later. And finally, one of the things we talk about a lot at Yammer is that we need to be ready to be wrong. We're going to make mistakes, but as long as we're ready to acknowledge those and recover from it and learn from it, we're going to be okay. I think we've rewritten our search stack about 3 times, but we've learned a lot in the process. And we have a solid stack now that has lasted. It works pretty well. This is the same in code, too. We look back at code that we wrote, just as the decisions that we've made. And sometimes we want to punch ourselves in the face for what we've written. Decisions about building services and how you organize can be the same way. So don't assume that the decisions you made yesterday are still the right decisions today. It could have very well been that the best decision at the time, but today that could be different. And this is really hard to do. Like I said, we still have a huge Rails app. And we haven't solved that problem yet, but we take steps to move closer to it. So that's all I have. Thank you, guys.
Any questions? So you said that you're working in teams.
Yes.
But how long does one team usually live long for?
Sure. So our teams, we kind of have this saying for it. We have 2 to 10 people on a team for 2 to 10 weeks. We find things that go longer than 10 weeks tend to just drag on at the end. So we try and break things into chunks that are no more than 10 weeks. Yes?
What happens after the team disbands? You mentioned support issues.
Yes. So we have another cross-functional team called our support engineering team, and their job is to take care of those issues. Like I said, it gets a little bit harder because they're not familiar with the domain, but they'll learn those things. They know where to go to find those answers.
If the knowledge hub is well-factored, well-modularized, what's wrong with it? I mean, just size itself doesn't, it's not a reason.
Just speak loudly. So I couldn't hear it.
So, I mean, if the app is well factored,
Sure.
Is there any reason to move to service-oriented architecture? Don't you miss your monolithical app?
Yeah, there are some things that were much easier. It probably depends on your application too. We have a large Rails app that it's hard to reason about the whole thing, and I think that's a lot of the problem is just trying to keep all of this in your head. So you know how this thing works end to end. As you break it up into services, it's much easier to think about as this service is the thing that handles this, and this is what handles that. And you get all those things I said in the beginning with reusability and just being able to scale these things out easier. But it probably can be done that way too. That's just not the route we've chosen.
So yeah, hi. During the organizational part of the project, when you split it into services, how do you communicate over teams with the documentation, API, and so on?
So the question's about how we
Document the APIs and communicate the documentation changes to the APIs and so on.
Okay. So when a cross-functional team forms, one of the first things we do is we write a tech spec for it about all the changes that we're going to be making. And as we go through the project, we keep that thing up to date. So when any project ends, we have this kind of documentation of what happened during the project, the difficulties that these teams came across, the challenges they had, and just generally some of the trade-offs they made.
Do you have a single repository of all the documentation for all services, or just...
We have a shitload of Google Docs about it.
Oh, yeah, I see.
Okay, when you're taking decision about splitting some part of code to service,
Sure.
or do you have something like, I don't know, fix making extraction to engine, and then eventually move this to a separate service?
Historically, we haven't done that. It doesn't mean that we aren't going to or can't do it. It's just not something we've tried yet.
Any other question?
As I understood, you write separate documentation for agreement on the API you use?
Yeah, it's...
And why not use automate specs for that?
Sure. It's kind of it's pretty loosely documentation. It's a lot of notes that we've taken about the project. it's nothing formalized, and that's probably something that we should do. But this kind of allows us to keep moving quickly and just record a lot of the notes from the project.
All right. Thanks again, Brian.
Thank you, guys.